Saxon Algebra 1, Lesson 50. Polynomial equations, ordered pairs, and the Cartesian coordinate system. Recall that the degree of a term of a polynomial is the sum of the exponents of the variables of the term. 2x third has degree 3, the exponent of x. X has degree 1. It's the same as x to the 1 power. 5, a single number, has degree 0. You can think of it as 5x to the 0 power. The exponent is 0. X third yz has degree 5. You see, it's x third y to the 1, z to the 1, and 3 plus 1 plus 1 is 5. The degree of a polynomial is the degree of the highest term. For example, 2x third plus x plus 5 plus x third yz has degree 5. That's the degree of the last term there. If two polynomials are connected by an equal sign, we have a polynomial equation, and the degree of the equation is the degree of the highest degree term. Here's a polynomial equation, and it's a third degree equation because the highest degree term is the 3x third on the right there, and the exponent is 3. A solution to a polynomial equation in two or more variables is a specification of values of all the variables. Polynomial equations in two or more variables have an infinite number of solutions. For example, the first degree equation, x plus y equals 5, has solutions x equals 2, y equals 3, and x equals negative 3, y equals 8, as well as an infinite number of other pairs whose sum is 5. Now we consider ordered pairs. Solutions to polynomial equations in two variables are usually given as ordered pairs of numbers, where the order is alphabetical according to the variables. For example, some of the solutions of the equation y equals 2 times x plus 3 are 1, 5, 2, 7, 0, 3, negative 1, 1, and negative 2, negative 1. Each of these pairs is a single solution, though it consists of two numbers. For example, the solution 1, 5 means x equals 1 and y equals 5. It is a solution because y equals 2x plus 3 gives us 5 equals 2 times 1 plus 3. Now we consider the Cartesian coordinate system. By the way, the word Cartesian comes from René Descartes' last name. He's a famous mathematician and philosopher. In Lesson 37, we learned that the solution of an equation or inequality in one variable can be presented in graphical form on a single number line as shown here. This solution says x equals 4, and this solution says x is bigger than negative 2. The graphical solution to equations or inequalities in two variables cannot be displayed on a single number line. We must have one number line for one of the variables and another number line for the other variable. When the variables are x and y, we draw the x number line horizontally and the y number line vertically, and we let the number lines intersect at right angles at the origins of both. The positive values of x are located to the right of the origin, and the positive values of y are located above the origin. Here the origin refers to the common origin of both number lines. The x number line is called the x-axis or horizontal axis. And the y number line is called the y-axis or vertical axis. Their intersection is their common origin. The two number lines divide the plane into 4 quarters called quadrants, like this. We usually number them with Roman numerals in counterclockwise fashion. They are called the first quadrant, second quadrant, third quadrant, and fourth quadrant. Every point in the rectangular coordinate system is associated with 2 numbers called coordinates. These coordinates are ordered pairs of numbers where the first number is the horizontal or x-coordinate and the second number the vertical or y-coordinate. Here's a point graphed in the xy plane. Its coordinates are 3, 2. First number is the x-coordinate, the second number the y-coordinate. Here's another point. Its coordinates are -1 and 3. A third point. Can you say its coordinates? They are -2 and -1. And a fourth point. The coordinates of this point are 2 and -2. Notice we always give the x-coordinate first, then the y-coordinate. Here's how to graph a point in the Cartesian coordinate system. You start at the origin, that's the place where the 2 axes intersect. Then you move right or left along the x-axis by the amount of the first coordinate. And finally, you move up or down by the amount of the second coordinate. This can be understood by way of an example. Suppose we need to graph the point -3, 2. We pull out some graph paper, and we start at the origin. Then we move left 3 units because x is -3. And after we've done that, we move up 2 units because y is 2. So you always move left or right first, and then move up or down. This is the end of Lesson 50. Your assignment, problem set 50 on pages 204 and 205 of your book.